Hi viewers, welcome to all. Now let us see the introduction to Arduino UNO programming. So this is very simplest concept to write various C or C++ program and run all the programs on Arduino UNO board with the help of interfacing of board via the computer. So before going to start, we have to know the very basic information about Arduino. So it is a microcontroller. The heart of the Arduino UNO is ADMEGA 328P microcontroller, which can be programmed to perform various tasks. So Arduino UNO consists of microcontroller. So before going to see in depth of microcontroller, we have to know about microprocessor also. So very first microprocessor designed for 4-bit operation. So that is 4-bit microprocessor. So after that 8-bit microprocessor has developed. So 8080, 8085, 8086, these are all some of the microprocessors already invented. And 8085 is one of the main microprocessor which is used in various colleges to perform different tasks or different operations and to control different kind of real-time applications also. And 8086 is a 16-bit microprocessor. So after developing of this 8085 and 8086 microprocessor, the controlling applications can be done with the help of this microcontroller. So initially the 8-bit microcontroller has developed. So 8051 is a 8-bit microcontroller. After that, PIC microcontroller, ARM processor, Raspberry Pi, Arduino UNO, Arduino Nano, ESP32, Node MCU. Likewise, a lot of controllers and processors have developed according to the technological advancements. So in this Arduino UNO is very cheapest controller and also very user friendly to all the users and the programmers, which will help to run the C or C++ code and help to perform various tasks and produce the proper output at a time. So for that we use Arduino UNO. So it is open source. So Arduino UNO is an open source platform, that is both hardware and software designs are publicly available. That is it is for extensive community support and resources. So whatever input device you want to connect and output you want to produce, everything can be connected with via this different kind of input and output pins, and it produce the proper output. We can able to understand what kind of application or real-time concepts can be controlled. So it is a user-friendly Arduino IDE integrated development environment, makes it easy to write and upload the code to on the board, and it is a simplified version of C or C++ programming. So and various key features are there. Digital IO pins is the first key feature. So this Arduino UNO has 14 digital pins. Out of this 14 pins, 6 pins can be act as PWM, that is pulse width modulation pin, and it can be configured as either inputs or output pins. And analog inputs, there are 6 analog input pins that can read varying voltage levels. And USB interface is one important thing which can be powered and programmed via the USB connection and making easy to interface with the computer. And power supply is one of the important thing. So it can be powered via USB or external power source, that is 7 to 12 volt maximum voltage level can be send to this Arduino UNO for operating. Next, LED indicator is there. So that means simply only one LED is present in this Arduino UNO board, and this LED located in pin number 13, and it helps the troubleshooting and testing operation. So that means just we need to blink the LED, means the both on and off conditions can be done with the help of the single bit of LED, so which can be done in this pin number 13 connection. So next, compatible shields. Many expansion boards, that is called shields, added to the UNO to increase functionality. That is example. For example, we can connect Wi-Fi or Bluetooth or motor control. So that kind of connectivity can be done with the help of this compatible shields in Arduino UNO. So next applications. Arduino widely used in various projects. So simplified projects can be done with the help of this Arduino. And robotics, that is controlling motors and sensors for autonomous movement. So if you take some robotics, that robotic, with the help of robotic arm, we can move the robot from one place to another with the help of giving some signal, that is move right, move left, move front, move back. Like this, some control signal can be given to the robot, and based on this robot arm, we can able to move the robot from one place to another. So that kind of application can be implemented in the robotic concept for very cheapest cost. Next, home automation. So automating lights, fans, and other appliances can be switch on or off. Can be done with the help of this Arduino UNO. At the same time, data logging. So we can collect the data from various sensors and monitoring the environmental conditions. For example, if you want to measure the temperature, we can able to use the temperature sensor, and pressure or humidity, and with the help of light sensor, various sensors can be used for this specific application. For example, if you take a smart farming application, at the time we can able to monitor the real time conditions of particular crop field. So for example, the particular farming area, what is the exact temperature, what is the humidity level or pressure level, or in which time we need to switch on the motor automatically, and give the proper water flow to the particular field, etc. So all kind of environmental conditions can be monitoring with the help of this data logging applications. And interactive act, so creating installations that respond to the user input. So these are all some of the applications for Arduino UNO. Next, how to start with this Arduino. So initially we have to set up. So if you are going to write a program, so in C programming, normally we know with the help of hash include stdio.h, we start the program. So this stdio.h represent standard input output functions. So that library should be included in the header file. So for this purpose, we have to write hash include stdio.h in C programming. Similarly, hash include conio.h and hash include math.h, hash include string.h. Likewise, lot of header files can be included. So each and every kind of lines having some specific reason. For example, if you consider math.h, so you have to perform some mathematical operation, some integration or differentiation or some other mathematical operation. So for that we need to add this library file in this header file. At the same time, if you want to concatenate the characters or string, that is the string concatenation or string movement from one a memory area to another memory area, or you erase the particular character or you add the particular character. So all string operations can be done via this string.h library files. So that must include in this header file. So likewise, whenever you want to start the Arduino UNO programming, so initially you have to start with this setup file. So that is download and install the Arduino IDE on your computer and connect that Arduino IDE to the board and use a USB cable to connect the Arduino UNO to your computer. After that, you can write a code and start with simple examples like blinking the LED. So and upload, that is compile your code in IDE platform and upload it to the board. So now we have to know about general pin configuration of this Arduino UNO. So this is front view of Arduino UNO board. So in this we have first reset pin. So after that 3.3 volt power pin also there, and 5 volt power pin, and two ground pins, and voltage in pin. So these are all located in power area. So these six pins are under power pins. So next analog inputs pins. So totally A0 to A5, totally 6 analog input pins are there. So analog in pin numbers from A0 to A5. So this is the Atmega 328 microcontroller. So it consists of 24 pins. So this 24 pins are having the specific operations. So this power pin or analog input pin or digital input pin PWM. Likewise, various operation can be taken place in this each and every individual pins. So this is a in circuit serial programmer, and this is the reset button. Whenever you want to reset your program, we can just click on it, and after that again refresh your program, and reboot again, and run your program. So next this is a very first pin in digital pin side. So that is 0. It is not actually digital pin. So in this area it is located. So first pin is pin number 0. It is a serial in. That is for reception purpose. Only one bit of data can be received at a time. So either it may be 0 or 1. For reception operation, we have to use this pin RX, that is 0, and after that serial out, that is transmission pin, that is TX pin. Only one bit can be transmit at a time. So after that pin number 2 to pin number 13, totally we have a 14 number of digital input or output pins. So in this pins, this 14 pins can be act as a input pin or output pin. So that can be decided by the user or programmer. But all analog 6 pins are act as only input pins. So here out of this 14 digital pins, 6 pins can act as a PWM pin. Already I have explained this in previous slide. So which is used for pulse width modulation operation, and one ground digital ground pin also there, and analog reference pin also there. So apart from this we have a USB plug. So with the help of this USB we can connect our PC or laptop, and we can interface our Arduino UNO board with PC and to run the program, and you can control your specific application. And this is the external power supply. So we need to connect this external power supply with the help of this adapter. The direct AC source is now connected with this adapter at particular 3.3 voltage or 5 volt. Maximum of 12 volt can be given to this Arduino UNO board. So this is a crystal oscillator. It is very important thing which is used to generate the clock signal, and this clock signal should be stable signal. That is, to maintain the stability of the frequency generation, this crystal oscillator can be used in all kind of microprocessor and microcontroller. So this is front view of Arduino UNO board, and different 28 pins operation is taking place here. Next it is a top view of Arduino UNO. So the same thing is there. So here in power area 3.3 volt, 5 volt, and two ground pins. One more 5 volt, that is V in pin also there. So apart from this we have a 6 analog input pins. All are now act as input pins A0, A1, A2, A3, A4 and A5. So now this 0 pin is reception pin, and 1 is a transmission pin. It is a digital. So D0, D1. So after that D2 to D13s are 14 digital pins. This is actually the input pins or output pins. That means this 14 pins can act as input or output pin. It can be decided by the user, and out of this the 6 pins can be act as a PWM, that is pin number 3, and pin number 5, pin number 6, and pin number 9, 10, and 11. So, and after that, we have one more ground pin and I square C. This I square C is integrated circuits, that is a clock signal and data signal, and here the SPA serial peripheral interface is there, serial clock, and other operations can be taken place via this particular pins. So this is pin category. So power, and the pin name is V in 3.3 volt, 5 volt and ground. So V in is input voltage to Arduino when using an external power source. Whenever you use external power source, at the time we have to connect this adapter line with this V in, and it will produce the power, and it give it to Arduino UNO board, and it will function properly. And after that 5 volt is available. It is a regulated power supply used to power microcontroller and other components on the board. So what are the different components are available on the Arduino UNO board? Everything can be controlled and run with the help of this 5 volt, and 3.3 volt is another supply generated by onboard for voltage regulator, and maximum current draw in this 3.3 volt is 50 milliamps, and one more is ground pin, and reset pin is there. So reset the microcontroller is the function of reset pin, and analog pins A0 to A5. So it is mainly used to provide analog inputs in the range of 0 to 5 volt. Next, input and output pins. Digital pins 0 to 13s are there, and it can be used for input or output pins, and serial pins 0 and 1, that is transmission and reception operation can be done with the help of this serial bit, that is only one bit of data can be transmit and receive. And next, external inputs 2 and 3 to trigger an interrupt. So whenever the interrupt is there, that is external signal that is given to the controller to stop the current execution of the work, which is called as a interrupt. So for to trigger that interrupt, we can use this external interrupt pin number 2 and 3, and PWM pulse width modulation pins 3, 5, 6, 9, 11, which provide 8-bit PWM output, and SPA is the serial peripheral interface, and it is used for SPA communication, that is pin number 10, 11, 12 and 13. We will see that in upcoming slides. And inbuilt LED, that is pin number 13 to turn on the inbuilt LED. So if you want to on, we can on this pin number 13, and if you want to off the LED, you can switch off this pin 13 by programming. TWI, so it is used for TWI communication, and that is A4 and A5, that is serial data and serial clock. And A reference is the analog reference voltage or input voltage. So these are the different pin categories, and it is a technical specification for Arduino UNO. So microcontroller name is ADMEGA 328P. It is a 8-bit AVR family microcontroller, and operating voltage is 5 volt, and recommended input voltage 7 to 12 volt, and input voltage limits are minimum 6 volt and maximum 20 volt. Analog input pins 6 pins are there, A0 to A5, and digital IO pins are 14 pins, out of which 6 provide the PWM output, and DC current on IO pin is 40 milliamps, and DC current on 3.3 volts pin 50 milliamps. Apart from this, flash memory is there. The size is 32 KB, and out of this 0.5 KB is used for bootloader, and SRAM static RAM is also there, and the specific memory area limit is 2 KB, and EEPROM electrically erasable programmable read-only memory also there for 1 KB memory allocation, and frequency that can be generated with the help of crystal oscillator to generating the clock speed, that is 16 megahertz. So these are all very important specifications we have to know about whenever to attend the various interview. At the time we can remember this basic information, and if the Interviewer asked some basic question to design something with the help of this particular input values or some concept. We have to remember these values or parameters and apply to design the particular concept. So next digital pins 0 to 13. So purpose used for digital input and output. So each pin can be set as a input or output using the pin mode function. So pin mode is one of the important function. With the help of this function only, we are going to assign whether that particular pin is act as input or output. Next, PWM output pins are 3, 5, 6, 9, 10 and 11. It support the pulse width modulation for simulating the analog input. That is flicker fast between dim and bright. So continuously we want to uh, glow the LED and off the LED. So the blinking is happened. So we want to view that means at the time to give very less delay and blinking the LED or flicker that very fast manner. For that purpose, the PWM pins can be utilized, and pin number 2 to 13 can be also used for control the different things and sensing things. So that means if you want to use some input device or output device, like means different sensors like temperature sensor, pressure sensor, humidity sensor, ultrasonic sensor, that can be used here as a input device, and some LED or control motors. It may be a DC motor or stepper motor. Likewise, whatever you need to use at the same time, some switches also can be used. So everything can be connected with the help of this pin number 2 to 13. So next analog input pins A0 to A5. So main purpose is to read varying voltage level from 0 to 5 volt and convert them into digital values. That is 0 to 1000 to 1023. So that is the resolution of 10 bits. That means the distinguish between the 1024 values in between of 0 to 5 volts by using this analog read function. So analog read function is an important keyword which is used to read the analog data in the particular analog sensors or some other input devices. And the next use cases typically used for reading values from sensors like temperature sensor, light and or pressure sensor, etc. Next, power pins V in. So already I have informed supply external power to the board, and the maximum recommended voltage levels are from 7 to 12 volt for that is the DC voltage, and 5 volt it provides a regulated 5 volt output from the onboard voltage regulator, and use this to power external components also. And 3.3 volts provide 3.3 volt output useful for powering certain low voltage components. So very few components are working in very low voltage. So for that we can prefer this 3.3 voltage utilization, and ground pins are also very important thing. So with the help of this ground only, the proper voltage can be given to the entire component to function in proper manner. Next, reset pin, and this pin mainly used to reset the microcontroller when connected to ground, and it can be used to restart your program. So next, communication pins TX, that is pin number 1, transmit the pin for serial communication. So it likes Arduino's mouth. So that means you are going to send. So for this TX, that is transmission pin, and RX is the pin 0, that is receive pin for serial communication. It's like Arduino's ear. So that is the main concept. So mouth will transmit and ear will receive. So for this is the concept behind this transmission and reception pin. And next is SDA, that is serial data line. So it is for I2C integrated circuit communication, and SEL is the serial clock line for I2C communication. Next, other pins A reference. It is used to set a external reference voltage for analog inputs, and LED pin 13, built-in LED connected to digital pin 13. So next, in circuit serial programming ICSP. It is a method to use program microcontrollers like Atmega 328P found in the Arduino UNO. This allows you to program the chip without needing to remove it from the circuit board. Next, ICSP header. So Arduino UNO features a 6-pin ICSP header, sometimes labeled as ISP, and these pins are typically arranged as MISO, MOSI, and SEK. So MISO is nothing but master in slave output, that is data line for reading from the chip. So what are the different information which is present in this chip that can be read, uh, which is done with the help of MISO. Next, MOSI is the master out slave in, that is data line for writing to the chip. So if you want to store some data on the chip, that operation can be done with the help of this MOSI. And SEK is the serial clock signal for synchronization. So synchronization is very, very important thing. Whenever you transmit and receive, both clock signal should be same both in transmitter side and received side. Then only we can able to transmit the proper signal from sender to receiver. So serial clocks should be synchronized properly. Next, reset pin. It is reset the microcontroller, and VCC is the plus 5 volt power supply, and ground pin is there. And these are some of the advantages of ICSP. There is no need to remove the chip. So sometimes if you perform some microcontroller operation in olden days, we have preferred Kale software, RAID software, etc. At the time, if you want to change your program and change your codes repeatedly with the help of this Scale or RAID software, each and every time we have to remove the microcontroller or microprocessor chip and load it. All the codes with the help of this loader, then only again we have to replace that, uh, that is erase that previous program and reload the program, and we fix it on the board and run the board. So in these are the different steps we have followed in previous or olden days, but nowadays there is no need of removing the chip on the board, so which is present inside of the chip itself and useful for bootloader installation. You can burn bootloaders directly to the microcontroller, and alternative to bootloaders uploading, in cases where the bootloader is corrupted or missing, there will be alternatives there, so that can be uploaded. So, and now the introduction to Arduino programming. So it is a process of writing code to control Arduino microcontroller boards such as Arduino UNO, and it involves using the Arduino IDE, that is integrated development environment, which simplifies the process of coding, compiling, and uploading programs to the board. Often these are called as the sketches. So these are the key concepts for programming of Arduino. And first concept is programming language. You have to decide in which language you are going to code it and run the particular Arduino board with the help of a different input device and output device. So next, structure of a sketch and variable and data types to be used, control structures, and after that functions. So programming language, Arduino programming primarily uses a simplified version of C or C++. In first slide itself, I have explained this. This makes it accessible for all the beginners and while still being powerful enough for advanced projects too. And the structure of a sketch, it has a two main functions. One is setup and another is loop. So in setup, the function runs once when the board is powered on or reset. So it is mainly used to initialize the setting such as the pin modes and serial communication. In loop, the function runs continuously after setup completes. It contains the main logic of your program, allowing to board respond to inputs and what kind of operation to be performed or perform tasks repeatedly. The variables and data types, you can use different kind of data types and variables, that is define variables to store data such as integers or floating point numbers or characters like C. And control structures, standard programming constructs like if statement or loop statement or while loops, etc., can be used for controlling the flow of the particular task of program. And function, so you can create a custom functions to organize your code and make it as a reusable. And basic programming steps: set up the Arduino IDE, download and install the Arduino IDE from the official Arduino website, and after that you can connect your Arduino by using the USB cable to connect your Arduino board to the computer and write a simple program. So initially we start with the blinking an LED connected to the pin number 13. So for that I have written a small program. So initially we have to set up our Arduino UNO. So for that we have to use void setup, that is we are going to initialize it, and pin mode 13 comma output. Now I am going to assign this 13 pin is the output pin. So because this pin has LED, so this is in pin mode and 13 and now act as a output. So I have to set this pin 13 as an output. After that I have to perform this LED should be on and off. So for this purpose I go to void loop. In this function I have to perform digital write operation. So for this, I have to take this 13th pin, comma high. So it represents I am going to enable or switch on this LED with the help of this giving command high, and which is taken place in pin number 13, which should be written on this digital write. So for this we have to write this digital write of 13 comma high. At the same time digital write of 13 comma low. So these particular function is used to switch on this LED, and this particular line is used to switch off the LED. So continuously this will be on and off, on and off. So for that you have to give some delay which is used to differentiate for which time or how much duration it is in on condition or off condition. That can be determined with the help of this delay function, and in this delay function we have to give some time period. So in Arduino 1000 is a fixed period, so which represents the 1 second. Similarly, again you have to give some time delay which is equal to 1000. So 1 second time duration is given. So when you write this program on the Arduino UNO board, and which is connected with this computer, and also you have to write this program on Arduino software and open source platform, and if you run it automatically the LED which is located in pin number 13 will glow and off continuously with the 1 second time duration. So this is very basic information, blinking of LED for a beginners. So likewise we can see lot of examples in future. So this is upload the code. Click the upload button in the IDE to compile your code and send it to the Arduino board and monitor your output. So for that in Arduino software we have a serial monitor. So which is used to monitor what kind of data we produced. Everything can be displayed in the serial monitor. We can view it, and if you want to change the data, that can be changed, and again we can run the program and we can see it on the serial monitor. So this is a very basic information we have to remember about Arduino UNO. So I think hope everyone understand these concepts. All of you watch my videos frequently. If you have any doubts, ask me. Surely I give some comments. Always I will support to enrich each and every individual person. Um so thank you all.